In today's video, we're going to be covering automotive batteries. The battery is going to provide power for parasitic loads that are on the car. Also, if you turn the key on to the accessory position, anything that you're running without the engine being turned on. It's also going to provide all the electrical demand while you're cranking the engine over, both for the starter motor, fuel pump, computers, anything that's on while you're cranking the engine. Provides for electrical power if your loads exceed the output of the alternator. Back in the days of the generator, the early days of the alternator, that happened quite often while you were driving. With today's higher output alternators, much higher output alternators, it's pretty rare for that to happen. The last one on here, this is important to remember this one, it's a voltage stabilizer for your system. The alternator is trying to keep the battery charged. Take the battery away, some alternators will quit working when you do that. If you want to know if your alternator is working, don't disconnect the battery. Watch a light bulb. With the engine running, when you shut it off, it's going to drop down a couple volts. You should be able to see the light dim. That's your assurance that the alternator is working. What's going to happen if you disconnect the battery while the engine is running is as you pull the cable off there, it is going to arc. The battery is the best protection for a voltage spike that's on the system. And right when you take that best protection away, you spike the system. You can damage electronic components on the car by doing that. Inside of the battery, looking in this lower corner right here with this semi-transparent battery, you can see that there's the six cells inside of there. Each cell on a fully charged battery is going to be 2.1 volts, giving us 12.6 volts on a fully charged lead acid battery. Inside of each cell is going to be alternating negative, positive plates. There's going to be one additional negative plate in order to make it work correctly. There's separators in between there. The manufacturers years ago changed from separators like this to a sleeve that plate actually goes down inside of. During your normal charging, discharging, the active material will flake. By having it inside of that sleeve, the flakes will drop down into the bottom of the sleeve and will readhere, giving you a longer life. As you read in some books, they will give you the whole chemical process taking place of what's happening inside there. I don't really care about that part. This is what I want you to know. Positive plates are going to be made out of a lead peroxide, so I have those in red here. The negative plates are going to be a sponge lead. Your electrolyte solution is going to be water with 36% sulfuric acid. You will read on some that they will refer to the positive plates as a lead dioxide. I'm not a chemist by any stretch of the imagination. From what I understand, the peroxide, dioxide are pretty much the same thing. Connect a load up to this battery. Current begins to flow. Chemical reaction takes place, so keep it in mind, a battery does not store electrical energy. It stores chemical energy that's converted to electricity. While it is discharging, your positive plates are going to change to a lead sulfate. Negative plates will change into a lead sulfate. Your electrolyte will become water. This is a fully discharged battery. This is a fully charged battery. Reverse the process by hooking up a alternator or generator on there. You reverse the current flow through there, and this chemical process will reverse. You get your fully charged battery again. This process of taking a battery from fully charged to discharged, back up, that's what they refer to as cycling the battery. Automotive lead acid batteries do not like to be cycled. You don't want to do that with them. The other thing I want to point out to you is here on a fully discharged battery, both your positive plates and your negative plates are lead sulfate. If somebody hooks the battery charger up backwards, lead acid battery will charge backwards. Because you have more negative plates, now you have more positive plates. It's not going to work correctly, but it can be done. Over time, your active material, so your lead peroxide, sponge lead, will begin to crystallize. Once it crystallizes, it can't make that conversion back and forth between the lead sulfate and the sponge lead or lead peroxide. This is what they refer to as the battery being sulfated. Over time, this process gets worse and worse. So testing a battery to figure out if it is sulfated or whether it's discharged. When I learned how to do this, what we were using was the Sun VAT40 machine. You can see hanging down here in the corner, you have large battery cables, just like jumper cables. Once you get your cables hooked up, You're going to load it up to half of the cold cranking amps. So if you have an 800 cca battery, you're going to load it to 400 amps for 15 seconds while watching the voltmeter down here. If the voltage drops below 9.6 volts, stop the test. It just failed. Whether it took 2 seconds to do it or 14 seconds to do it, it failed the test. It can be either a discharge battery or it can be a sulfated battery. The next test that you're going to do will determine that. If it failed the load test, you're then going to do a 3-minute test, which means you're going to put a battery charger on there, monitoring the voltage. You're going to put the charger on high, so about 40 amps or so. If a battery is discharged that just failed the test, it will easily accept a charge. So the voltage from your charger will stay low, battery will charge up. In 3 minutes, if the voltage stayed below 15.5 volts, battery is discharged, it's still good. This test is a really good test, the best test that's out there, if your battery is 100% charged when you did the test. If it's discharged before you start, then that is not an accurate test. The new way of doing it is using this machine down here, which this one is Midtronics. There's other manufacturers that make it. This hooks up to your battery, and you can see, man, you're not going to put a load on this thing like half of the CCA. That would fry this little machine. What this machine does is it puts an AC voltage through the battery, and it measures the impedance or the resistance of the battery, which normally you wouldn't think about resistance in a battery. But if you think about your generator is working to recharge the battery, that means the battery is the load. It does have resistance, and it'll give you a reading of how much life is left. So on this one up here, I showed you 2 results. Looking up at the top here, you can see the results of a couple different batteries that I tested. First one was 500 cca, and it showed that there was 309. It passed the test. It's saying it's a good battery, but it's saying the battery is discharged. Second battery was a 550 cca battery, tested out at 305, 12 volts. So again, battery is still good, but it was saying that battery needs to be charged. It can identify the difference between a sulfated battery and a battery that needs to be recharged. The advantage of this system here with using these Midtronics or machines like that, your battery does not have to be fully charged to do this test. Evolution of the battery, going back 40s, 50s, we were using the 6-volt batteries, and that's what you see up here behind my image is this 6-volt battery. You can see there's just 3 cells there. These were a maintenance battery, and literally when you bring the vehicle in every 3,000 miles for an oil change, you were checking the water in the battery, and most of the time they needed to have water added. When you're adding a lot of water to the battery, if you're just using tap water, the impurities that are in the water get into the battery and can start shortening it out, shortening the life. That's why you'll hear to always use distilled water to get those impurities out. Today's batteries, if you add water to a battery, it's going to be maybe once. They then changed over to a maintenance-free battery. This was late 60s, early 70s when they made this transition. This was during the muscle car era when we're having big engines. So if you had a 5.7 liter engine, that was really fairly small for that time. We needed a lot higher CCA. The maintenance-free battery could give us that. Advantage to the maintenance-free battery was the high CCA, but you couldn't put a small drain on there because they didn't have much reserve capacity. Advantage, high cranking amps, could store the battery for a long period of time. Worked good that way, but the 2 disadvantages, or 2 of the disadvantages, 1, they didn't have much in the way of reserve capacity, and 2, they also had this nasty little habit of these little lead fingers growing out from the plates, and once it came off from a negative or a positive plate and touched the plate next to it, it would now short out that cell. Next evolution was a hybrid battery, which was kind of a combination of the 2, giving us the higher CCA than the original maintenance batteries, but without having the disadvantage, so they had a higher reserve capacity. Most of the batteries that you're using today are in that hybrid category. The next evolution was the recombinant battery, which Optima was the big name in that. Biggest difference in there, no longer a liquid electrolyte, it was a gel electrolyte. The case could crack on here and nothing's going to leak out. You could also mount these sideways, upside down, they didn't vent. Really good battery, high cold cranking amps, good reserve capacity, Because they didn't vent, corrosion wasn't near the problem with these type, and typically you could get double the life of the recombinant battery than you could from even the hybrid batteries. They also had the valve regulated batteries, which is basically, it's a little bit fancier for the hybrid batteries. And the last one that they have is the AGM, or absorbed glass mat batteries. And these are the latest and the greatest for the lead acid. They do have a liquid electrolyte in there, but if you were to open it up, you wouldn't see the liquid inside there. The fiberglass matting that they have in between the positive and negative plates absorbs your electrolyte. They also compress these and jam them down into the cells because they're packed in there so tight. They don't have to put in the reinforcing. The lead by itself is very soft metal. You took the lead like this, it would just fall over, couldn't stand up. So on our maintenance batteries, maintenance-free, the hybrid batteries, they have to put other metals in there to stiffen that up. Well, that added resistance to the circuit. It also gave you less usable material or active material. With the AGM, you can see on this one here, 99.99 pure lead. It's all active material that's inside of there. It's packed in so it can't fall over. It can handle the vibration, again, because it's packed in so tight. Because you have so much active material, look at the cold cranking amps, 930, and that's really high. The reserve capacity is 135. Most of the batteries that you would find would be 100 to 120. If you're looking for a battery and you got the money, AGM's the way to go. And I'm not necessarily promoting North Star. It's just that was where I had the images from. Specific gravity of 1.0 is the weight of water. Any number that is greater than 1 is heavier than water. The sulfuric acid that's added to your electrolyte solution, sulfuric acid is heavier. With the 36%, fully charged battery will have a specific gravity of 1.265. That's a full charge. As you begin to discharge the battery, that sulfuric acid gets deposited onto the plates, and you have more water, less sulfuric acid. 75% is 1.225, on down like that. For most technicians working in the automotive field, if you go to take the ASE test, memorize a couple of these so you can remember them when you take the test, because they'll have a question or two on this specific gravity. Because we're using sealed batteries, you'll rarely, if ever, test a battery. They do have these hydrometers. This one over here is a cheap hydrometer. You're going to pull the cap off, stick this part down inside of the battery, and then this bulb up here, you squeeze that, draw the electrolyte up in there, and then it's going to give you your reading. This one here is going to do the same thing, so it's going to have the same stem that goes down there. It has the bulb up here. And this part right here floats. And zoomed in on the image here. As it floats, you're going to see, okay, the electrolyte level comes out to the G right here. Then you look at your thermometer. Thermometer tells you the temperature, and on this chart here, you go to where it intersects for the letter that you had, the temperature that it is, and that will tell you your specific gravity. Batteries work best at 80 degrees. Get them colder or hotter, and they don't work as well. Your chemical reaction is going to be affected by the temperature. That's why the good hydrometers also have a thermometer on there that are measuring the temperature of your electrolyte. Battery posts. Over here, top post, this is what you're going to find on most all the cars that are out there. GM, back in the 70s, started using this side post battery. GM was saying it was better in that they don't corrode. I have seen many that corroded. The reason that GM said they don't corrode is because a lot of your corrosion happens here on top of the battery. So as your battery gases, you have a horizontal surface. Those gases stay on top of there and are very corrosive. They are more prone, the top post is more prone to corrosion than the side post is. It's not that it's not going to corrode, it's less likely to corrode. Most guys working on cars don't like the side post because if you go to jump start, there's not much for it to grab onto at that point there. Top post, most of them, side posts. The L terminal, I've seen those on like lawn tractors and stuff like that. I've never seen it on a car unless somebody stuck the wrong battery in there. Parasitic drain. 50 milliamps maximum. There's a few manufacturers, Mercedes being one, BMW being another, that on some of their models, they will have greater than 50 milliamp draw. They're either going to put a really high reserve capacity in there, or they'll even put 2 batteries in. If you have a customer brings a vehicle in, and the customer complaint is the battery goes dead after it sits for a while, you check the battery's good, you check the charging system's good, that battery shouldn't be going dead. Now you're going to check for an excessive parasitic drain. To do it correctly, you want to get a tool like this, and this is going to be a battery isolator. Remove this piece here. This is an adapter for a side post battery. This goes on your negative posts. Negative cable connects here. Keep this turned down so it's closed. After you get it on there, start the vehicle, run it, turn your accessories on. Shut it off, get your meter hooked up. Black lead to the negative post, red lead to the cable. After your amp meter is hooked up, open this switch. So just turn it counterclockwise, turn and a half. That will open up the connection. Now the current's going to flow through your meter. So make sure your meter's on a 10 amp or whatever your higher amperage is and get your reading. If you do this really quick after you shut the car off, you'll find that it's a fairly high amperage, 2-3 amps, maybe even a little bit more. It's because there's computers that are still going through a shutdown, and you're seeing those. That's also the reason that you're using this tool instead of disconnecting the negative cable and then hooking your meter up. If you have a computer that won't shut off, when you disconnect the cable, that computer loses voltage, it shuts off, and now when you hook up, the computer will not turn itself back on. You'll not find that type of problem. Tool's hooked up, amp meter's hooked up, you open the dial, and you find there's 250 milliamps. So 5 times the amperage that you want to have on there. Now you go over to your fuse box, start pulling the fuses out. Most of the time you can pull the fuses out one at a time and find it. When you pull a fuse out and it drops down to 32 milliamps, that's your fuse, that's where the current's flowing. Now get in the service manual, find your fuse block details, find out what's on that fuse. Go see if one of those is not shutting off, or maybe the customer has done some customizing to their vehicle and they hooked something up, such as a phone charger or something like that, on that circuit. And when you're doing that test, when you come across the maxi fuses, you don't need to bother pulling the maxi fuses out, because those maxi fuses feed the smaller fuses once you pull those smaller fuses out. The reason I said most of the time you can do it with one at a time, there are some manufacturers, Nissan is one that does it quite common, but other manufacturers have done it too, is they will have 2 fuses, so like 2 10 amp fuses that feed one circuit. If you pull just one out, current will flow through the other one, you put that one in, pull the other one out, and it goes through the first one. You'll never find the problem. But if you go through and you can't find it with all of them, got to pull them out and leave them out, see if you can find it that way. The alternator, if the regulator and the alternator has gone bad, it can keep the alternator turned on. It's not fused on there. You can't find it through the fuses, disconnect your alternator and see if the problem goes away there. Battery ratings. Most important one, I think, for today's batteries is, or today's vehicles, is a reserve capacity, because we have so many computers that are staying on and putting a small draw on the system, especially if the car's going to sit for 2 or 3 weeks. You want to have a lot of reserve capacity so that when you come back to the vehicle, you can still start it. Back in the days of the big engines, or if you've got a truck with a V8, cold cranking amps is probably going to be more important than your reserve capacity, because you have the bigger engine, you need to get that cranked over. With smaller engines on most of the cars and a lot of computers and stuff, that's why I'm saying reserve capacity is actually more important. When I'm looking for it, I'd like to go with a minimum 120 minutes of reserve capacity. Battery size is your group number. Bottom line on that is, will it fit in the car? The width, the height, the depth of the battery to fit inside. Battery ratings, we talked about CCA. There's also a CA, or a cranking amps rating. On the Japanese manufacturers, they have a JIS, which is the Japanese industry standard. There is a DIN, which is for the German rating of the vehicle. Society of Automotive Engineers has also come out with a rating, and there's the IEC for the International Electrotechnical Commission. Here I brought it up from the battery test tool, that they have these different ones. You just choose, you look at the battery, if it has a CCA, just use that one, but if it has the JIS or the DIN, That's what you can use to be able to tell your battery tester what it's connected up to, and so it knows how to test it correctly. Battery cables, make sure that they're clean and tight, and you'd be surprised a little bit of corrosion can cause a lot of problems. The idea of a red being the positive cable and black being the negative cable, that is not true. Do not use that for your guide. I worked on one car that had the negative cable was red and the positive cable was black. Look for the plus or minus that's on the battery. Negative battery cable is going to connect to the body as well as to the block of the engine, because we have a lot of electro accessories now, so the body of the vehicle needs to be grounded well. Positive cable is going to connect to the starter motor and to your underhood electrical center. And again, make sure that they're clean and tight. To make the battery last, you will be asked by people, hey, how long should a battery last? If you live in an area that has fairly mild temperatures, such as the Pacific Northwest, batteries, if you bought a good battery, it should last you at least 5 years. If you bought one of the cheaper batteries, you may be looking at 3 to 5 years, somewhere like that. If you were living up in Alaska or down in Arizona where you get the really hot temperatures, you may be replacing that battery every couple of years. They just don't last as long because they don't like those extreme temperatures, especially on the cold, where the colder the battery gets, the less output it has, and the engine requires more energy to get it started the colder it is. Second factor is vibration. If you have a bungee cord over your battery, or you took a hanger and bent it so that it's holding it down, that battery is going to be bouncing around, it's going to vibrate, you're going to shorten the life of the battery. They can't handle the vibration. Make sure the clamp is down tight. If you've lowered your car so it doesn't ride near as well, it bounces a lot more, you're bouncing the battery. It's not going to last as long. The electrical load, again, the bigger the engine. I showed you on that one test where it was a 550 CCA battery and still had 304 cranking amps. If you have a small 4-cylinder or 2-liter, it's going to draw 150, 170 amps, somewhere there to crank over. 300 cold cranking amps, it's still going to last a long time. If you have a 300 cubic inch engine or larger, that 300 cold cranking amps is now getting close to what you require to crank the engine over, especially on a cold morning. The clean and dry, you can take some batteries and you'll see that they're wet and dirty like this has here. Voltmeter, connect the negative battery lead to the negative battery post and touch the top of this battery with the red lead. I've seen 6, 7, 8, 9 volts. And what you're measuring is a voltage drop. Current is flowing right across that wet, dirty surface of the battery. The battery needs to be clean and dry. The corrosion, when you see it like this, baking soda and water. When it gets really bad like this, what I do is take the baking soda and water, put it in a cup, take this terminal off, stick the terminal in the baking soda and water, and just let it sit there and bubble away, work on something else. Come back, when it stops bubbling, pull it out, use a wire brush, scrape off, because the corrosion gets really hard inside of there, so scrape off the stuff, stick it back in. When you can scrape it off, stick it back in, and it doesn't bubble anymore, now you've gotten all the corrosion off. Now you're getting ready to put it back in. Keeping the battery fully charged. If it sits discharged, it's going to shorten the life. If you're the type of person that is constantly leaving things on, such as your lights, and killing the battery, again, that's going to shorten the life. On those maintenance-free batteries, if you cycle that battery 5 times, they were pretty well shot. Tools for working on the battery. If you're adding water, this is the tool. If you go back in the 50s or 60s, there was not a gas station or shop anywhere that didn't have at least one of these. This part right here would go down inside of this hole. Then you pushed down on it, and it would put water in, but it wouldn't overfill. Where this plastic comes down to the bottom, the water or your electrolyte solution has to be below that. If it comes up above that, as the battery gases, it'll start taking more of the water out with it. Water level or electrolyte level needs to be below this, but above your plates. Because we're not servicing batteries anymore, it'd be hard to find one of these tools. The battery pliers, these right here. The nut that holds the terminal is typically a 10 millimeter, some 13 millimeter. When you go to put a 10 or 13 millimeter wrench or socket on there, it just slides around. The reason is because the battery acid has eaten away at it and made it smaller. That's what these pliers are for, is to be able to get those off. If you had to use this tool to get the net off of there, replace the net. Don't just put that one back on. Once you get it loose, and then you'll find that the terminal does not want to come off the post, that's what this tool is for. Grabs a hold of the battery cable down here. This pushes down on the post, so all your tension stays right in there. Do not want to pry on against the case. If the case is plastic, you can break the case. You really want to have one of these tools for two reasons. One is if you come across that cable that doesn't want to come off, but two, windshield wiper arms. The ones that have the net on the top, once you get that net loose, that arm doesn't want to come off, this tool works great. The battery strap, this one here, or the carrier, especially if the battery's in a kind of a tight spot to get where you're carrying it, this makes it a lot easier to handle the battery. The baking soda and water, we talked about that. Cleaning the posts, this wire brush that probably most of you have in your toolbox, throw that away. When your terminal or your post begins to corrode, when it first begins to corrode, this would work, will do the job. But when it gets to be a really dark gray or even black, man, that metal, that lead has become so hard, this wire brush won't touch it. This is the tool that you want to use. It's got a positive negative over here because your positive negative posts are different size. Make sure you use the correct one. You're going to push it all the way down, turn it 360 degrees and slide it back off. Then take a look to see how well it cleaned it up. You might need to do it a second time. This part here cleans the inside of the battery cable or the terminal and gets all the corrosion off of there. When you go to put the terminal back on, if the terminal does not want to go on, don't hammer it or force it down. Again, you can knock that post down inside of the battery. These battery terminal spreaders will open it up so you can get it down on there. Jump starting. Number one, get yourself some good jumper cables. These jumper cables right here, you can look at the difference between these cable ends and these. These are cheap. They don't have a lot of tension. They're not going to bite very well. Two, this cable, they put thick rubber insulation on there to help make them tangle proof, but it's probably going to be like a 12 gauge wire inside of there, where these are going to be like a 4 gauge wire. It's got the end that will bite onto a side post, a lot more tension. Make sure you get good jumper cables, or get yourself a really good jumper box. So this is showing this vehicle here. It has a good battery. This one's the battery's dead. Then showing hook up the positive first, hook up the negative. The last connection is away from the battery. That last connection will arc because you have a discharged battery and a charged battery, so the last connection will always arc. The battery's gas, so you want to make sure this last connection is well away from the battery so it doesn't arc. And it would probably be a good idea even your last connection be over on this one, because it's more likely this battery has been gassing. Once you get it connected up, start the vehicle, give it about 1500 RPM, let it run for a minute or two, let it get some life into this battery, and then try to start it up. When you go to take them off, this is the one, that one that's away from the battery. Disconnect that one first, because again, it's going to arc when you go to take it off. Storing the battery, keep the battery in a cool, dry place, clean it off, any corrosion, keeping it dry on top, and then use a battery maintainer. This is just an example of one. These are typically like about 3 amps, give or take, but they're automatic. It's just going to maintain the battery at a full charge, so it monitors the battery voltage. As soon as the battery is fully charged, it shuts off, but it continues to monitor the battery voltage. Voltage drops down a little bit, and it'll charge it back up. For people who have RVs or boats where it's going to be sitting for a long time, then you got to have one of those on there. For the battery charger, when you're going to charge a battery, if at all possible, if you have the time, do it on a slow charge. It's much better for the battery. Realistic, time is money. A slow charge is not always an option, but when you do it, use an automatic charger. They'll still do a fast charge, but they won't overcharge the battery. These older chargers like this, they will overcharge the battery. My recommendation is get rid of these old chargers, get the newer automatic chargers. For battery safety, keep in mind there is acid inside the batteries. It's very corrosive. It will eat away at your clothes. It's not good for you to get on your skin. It's especially bad to get it on the paint of the vehicle. Always handle that with care. Disconnect the negative battery cable first. When you're connecting back up, negative battery cable last. The battery is a flat horizontal surface. Keep in mind it is not a workbench. Don't store your tools on there because it can short out against the two posts. And here's an image of a battery that did explode. So I have had a battery explode on me, put me in the hospital because I got battery acid in my eye. Treat them accordingly. Traction batteries. The traction battery, this is in your hybrid and electric vehicles. They have used lead acid batteries. The Saturn EV1 used the lead acid batteries. And if you've seen the movie Who Killed the Electric Vehicle, take that with a grain of salt. The industry was not ready for electric vehicles. Who wants to buy an electric vehicle and at 30,000 miles spend several $1,000s to replace all the batteries in there? Even though, yes, they made the Saturn EV1, it was good for learning, but it was not good because the battery technology was out there. A few manufacturers have used NiCad batteries, which the NiCad has a higher energy density than the lead acid, but it also had that memory effect. And that is, if you discharge the battery halfway, charge it back up, discharge it halfway, over time, the battery will be convinced that a 50% discharge is 100%. And then you can't get that last part. NiCads, about once a month or so, you need to discharge them all the way down and charge them back up. The nickel metal hydride, which is what the Prius used, Ford's used it, some of the other manufacturers have used it, had a higher energy density than the NiCad, but it didn't have the amperage that the NiCad had. So you had to have more batteries hooked up in parallel to get the amperage there. Lithium, higher energy density than the nickel metal hydride. All of your electric vehicles and hybrids, at least the hybrids that can go 30 plus miles on strictly electric, they're all using lithium of one technology or another. Disadvantage of the lithium is they can get hot, they can catch on fire. Once they catch on fire, the battery itself provides both the oxygen and the fuel. The only thing that you can do, call the fire department, they can empty their whole 500 gallons of water on this battery and they're not going to put that fire out. The only thing they can do is contain the heat within the battery area. And the part that I missed on here, and I had forgot to put it in, was back up in here, that once you've cleaned the battery, when you're going back together, put some battery terminal protector on there. Noco NCP2 is one brand name, but go to any parts store, ask for the battery terminal protector, and you spray it on the bottom of the cable, on the post, top of the cable. You put the cable on, tighten it up while it's still wet. As it clamps down, it'll push all that out of the way, so it'll still make good contact, and then tighten it down. Primary thing, you're trying to keep the oxygen away from there so it does not oxidize, which that's what your corrosion is. So that's it for this video.